I may fall back to an older NQE, but I'm using 3.3.0.16, and this supports job limits. And also CSA accounting. Are you running it now?
Mm-hmm.
So before I start an NQE, I have to build the database called UDB, User Database or User Limit Database, ULDB. That's done with a gen limits command. And it basically takes a file called ITC jlimits.ini and then creates a binary version of it. ITC/jlimits. So I may regress out of that. I have been having problems with it in my last class as well, but right now I'm looking at this saying it's doing a get jlimit, job not found or not part of job, error retrieving job limit values. Okay. And I may try different versions of NQE to get around that. Now, we may as well take notes because this isn't really documented anywhere yet. This is just for NQE, but in ITC NQE info, it defines all the NQE configuration parameters. And again, PBS and LSF don't support this yet, but I've added 2 additional arguments. So to get this job limits, I have to have what's called EOE SW jlimits installed. And that's where the genlimits command comes from, is that package, along with a jlimits command and also a jstat command. Okay. And then in ITC NQE info to turn this stuff on, I'm putting in a NQE NQS kernel jobs. That's turning on the job limits capability. So what this means is the kernel is going to keep track of resource use, and if the program exceeds the limit, the kernel will kill the process. And my problem right now is I'm hitting open file limits, number of processes that I'm trying to fork and stuff like that. The second one then there turns on job accounting, CSA accounting. So I've set both of those to 1, NQE underscore NQS underscore job underscore, or kernel underscore jobs. And CSA underscore ag. Now, unfortunately, with job limits installed, diagnostic messages are not very clear. And most of your compute server sites are going to be running job limits. In fact, a lot of them are running job limits earlier than they should. Just because the feature was implemented doesn't mean that NQE knows how to use it, for example. So this new version, this 1.16 version, if I do a qstat, I can see that I am running 3.3.0.16 as my version. Now what's happening though is when I submit work, my jobs are failing, the forks are failing, and then queues get shut off. So the status field here is going to off after a while. And again, I'm troubleshooting this as we go through the week. Find the latest one. And there's the messages I'm getting right now. Cannot fork too many processes. That may not be processes, again, with job limits. It simply means the fork is failing. Children inherit the limits of the parent, and if that exceeds the job limits, you still get this kind of message. So it's a very misleading message.
Yeah, so these shells said it can't fork.
even down here.
Profile cannot fork.
Yeah. Anything running in the job, it can't have more than one process running, it looks like. And here we've got this exceeding job limit value. Limit name is number of processes. Now this happened to me before when I forgot to run the gen limits. So I started up NQE, but there was no binary ITSE J limits file yet. So NQE came up without any limits. And then I was getting this sort of message. But during lunch, I brought down NQE, checked on this package, and I went into jlimits.ini to edit it. And let me take a look at that now. I think it's jlimit. Let's just try.
J-limits.
Must have been.
Oh, you know what happened? Is it supposed to be INI or is it just IN?
That's why. I'm used to INI.
Oh. Microsoft hacker there.
Yeah. So in here we have a different set of limits for interactive versus batch, and I'm expecting the limit that I'm hitting right now is this one. But we're going to have to troubleshoot it as we go through the week. So this is the ASCII file. I go through and set my limits. Here we're at nproc at 1,000. That should be acceptable. And then I've got my batch limits. So if I log in interactive, I got those. And now I've got the batch. And I've got commented out examples too. We're not using the commented ones. So here's my batch limits that NQE should be getting for my job, but it does not appear to be getting the nproc limit correctly, or else the number of open files. I actually upped that. Question?
No.
These were smaller, and I upped them during lunch, and then shut down NQE and restarted NQE. And also did a new set gen or gen limits command. That was for batch, and then we've got another on a per user basis. So by default, we've got 3, interactive, batch, and 1 for miser. And if I'm not in the user database, I get one of these 3. However, I can pick out particular users and set them different from the default. Okay. So here the user root has got everything set to unlimited across all 3 domains, if you want to call them that. So if I log in interactive through the login command will use these to get my limits. If I log in with batch, these would be the limits, and then also if I submit to miser, I've got limits. So then I just did my gen limits. And I don't have permission, so that's good. Gen limits. There's a -v verbose. Now it says it parsed that job limits IN file that I just looked at, and then put it into the JLimits binary file. It says it successfully created that. Then I would shut down and restart NQE.
Use PAR.
Well, PAR is not going to help us at this particular second, but if I did PAR on the NQS daemon, that would be helpful, yes. So I could see it make the system call and everything.
Also give you the number of opens, wouldn't it?
Number of what?
You can see how many open files you had.
Yeah.
You want.
You'd have to see it from the open and stuff like that.
Yeah.
But PAR would be a useful diagnostic tool since it's system calls that are failing, forks that are failing, that sort of thing. Now, seeing this, my next intuition would be to look where? Where you go for normal diagnostics.
System log.
Syslog. So I was only interested in today. I can see when my logins are creating my job IDs and everything. And I'm not seeing anything else of relevance to me here. Okay, nothing else of interest to me. Again, this is the first time I've worked with this particular root system that I put together last week. Let me just double check here a few things. So during the reboot, I did pick up 6510. If I'd gone into root, I see Unix and Unix.bak. There would have been a Unix.install before as well. So Unix.bak is one from a July 31st class, and then the Unix that I've got now is one that was built today. Or yesterday, was it? Yesterday. Okay. So it looks like I'm running a 6510 instead of a 659. The other diagnostic area for NQE would be in var spool NQE, and then there's a log directory there. I'm just going to look at the NQS log here, go down to the end. And again, I can see that same sort of thing. We're hitting a number of processes limit. And that was the job we were just looking at. So for some reason, NQE is not getting the proper job limits. I'm going to talk to the developer to see if they've tested it on 6.5.10 yet, because there were some changes going on in this area because of this problem. Same sort of problem here. But don't believe that. That simply means forks are failing. And the forks could be failing for other reasons at this point. We're going to be doing this a lot this week, responding to what I've got on a live system. So there is a jlimit command, and jlimit would then show interactively what my limits are. So we had the limit command before, now we've got jlimit. This is for the whole job, not on a per process basis. Another command is jstat. So in this case, jstat gave me my current job ID that was assigned when I logged in. I can do a jstat-a and see all the job IDs for people that are logged in. And the one I'm interested in right now is jstat-al, which gives me all the limits. And I'm going to put that through more. So I'm just looking for limits that might have been hit. So here's my usage, here's the high value, and then here's what the limits are. And then the command. So I've got a shell, I've got a shell, I've got a shell. And I don't have the job running it at this point to actually see it assigned with the job limit. But everything there interactively had a job limit assigned to it. I was trying to troubleshoot this before I actually had you starting to submit work, but I'm just going to submit a job here now. Do a jstat-al. I'm just trying to find the NQS daemon, and I don't see it. But what I was trying to look for was, for example, here, we've got a particular session that has current value and max limit, current limit and max limit. And I might have been hitting one of these other limits, but this looks like the NQS job. These look like we're actually on the NQS daemon when it submitted it. Files was from 0 to 20, unlimited. Threads was 1, unlimited. Here.
Process was current limit 0.
Okay. So I've kind of isolated my problem, at least the fact that that job is getting a process limit. So it is a process limit at this point, not an open file limit that it seems to be hitting. And I think this is an NQS bug at this point. Because it's up to the NQS daemon to make that limit is coming up with 0 for all my jobs. Does that make sense?
I don't know, I'm lost in the conversation, to tell you the truth. I don't even know what you're trying to throw at you or what you're trying to do.
I'm trying to get NQS working.
Oh, okay.
And in the process of NQS working, when I submit my jobs, I was getting this failure. So I'm just going to do a head here again. Oops. And we're going to get into this once I get an NQS working, then we're going to be submitting our own jobs today. But I was trying to get a, since it's a new OS level and everything, I was just trying to get ahead of you. Okay. So when I looked at the job, it came back and it said this. Okay. And I also saw down here, exceeded job limit value, limit is number of processes. So when I am logging in interactive, my JLimit command would show me the same limits, and they're all unlimited. But I wouldn't be able to put it in the job because the job can't fork off the JLimit command in the first place. I suppose I could try something else here. VI. I'm just going to give it a try here and exec JLimit and exec JStat-L. So I'm trying to look at the limits as to why the forks are failing. So after I saw the forks failing and I knew that things were working before, but it's the job limits and this new NQE feature that I'm exercising, I went to the NQE side of it. So interactively I'm fine. It's when NQE starts the work that it changes the limits. So basically when I log in interactive, the login command gives you your prompt for your login and then your password. And then right after password, it goes to the user database that we looked up. And if I'm interactive, it pulls up the attributes and makes those as a call to the kernel to say, make my job limits unlimited. So when I did my JLimit, I see everything unlimited. Same thing would be true in the batch environment. I'm going to try submitting it now. Oops. Oh, it spelled it wrong. Now when I did a QStat on it then, I see only one process running on it. It should have at least 2 or more processes associated with it. So the only thing that appears to be running with it is the shell itself. And the shell is going through ITSI profile and dot profile and then the job's standard in and trying to execute the commands that are in it. But it's not able to do that due to forks failing. By the way, let me do a QStat here. Right now the status is staying on, but if the forks start failing, then the status is actually going to get turned off. Once the fork fails, it says forks are failing. Let's throttle back the workload and start turning off queues. Okay. So my next step then, if we still got the job running, and it is still running there, but it's not doing anything. I popped up top, and there's no code running there. So I'm going, well, where's my job? Qstat-A, and I still see the job sitting here with an R01. Okay. So then I did my JStat-A. Now I can see all my job IDs. Note that this job ID here for this code 1 is a job ID of 32. So there's the entry for that particular session, for that particular job. And my jobs are running with the Born syntax. Now let's see if I can do a JStat-L on that particular job ID. Oh, I need to specify a J option. So now I'm able to look at the job limits for that particular job, and that's where we left off, was I was comparing usage to currents. And I see processes are coming up with a limit of 0 for number of processes that the job can create or fork off. So that's why it's failing. Okay. So you're probably going to see this sort of thing as people upgrade. This product just came out 2 weeks ago. I used it for my first time last week of September. So it's just MR'd. In my last class I used 6.5.9. Now I'm using 6.5.10. I've got a different problem. So I'm going to talk to the developer during break, Dennis Parker, and find out if there's more about this. Perhaps it works in 6.5.9 but not 10. Question?
I'm trying to do the JStat myself. I keep getting this insufficient rights to retrieve limit values.
Uh-huh.
Is that you?
Did you use the A option too?
Yeah.
Yeah, the A says all jobs, and if I'm not root, I can only look at my own jobs.
Oh, okay.
So I was able to do a JStat-A, but then when I stuck the L on there, it would say the same that you were seeing. I get these insufficient rights to retrieve limit values on other jobs. I see my own, but I don't see the other jobs. If I SU to root, then my JStat-AL will show every job. Okay? Again, it looks like my job just finished at 32 JSTAT, so I'm going to do a JSTAT-A, and 32 is now gone. That was job number 8. And I submitted, here we are, it was job number 8. So I'm going to go back into my directory I submitted from and take a look at. And that's what was coming back in my job. So there are a lot of sites that have been hitting this. Usually it's the open file limit that they're hitting. So they're running an older NQE, and then all the jobs that NQE spawns off are under the NQE job limit. So if I fire off 500 jobs, I hit open file limits rather quickly. But now I'm hitting a process limit. And again, I'm pretty sure that that's going to be something that's a bug in PV BugWorks. So this is a new feature. This came out in 6.5.7. Okay, but nobody's actually used it successfully yet because the batch interfaces don't know how to make the call. So 2 weeks ago, we got NQE that knows how to make the job limits call now to override the defaults. And that's where I seem to have a bug, is in that particular area there. So I'm going to back off and regress to a older NQE until I can figure out what to do here. So this job limits is commonly being used in the compute server market. It actually came out of the Crave market originally, user limit database or user database. And the Egan developers are the ones that implemented it in IRIX. So I've got that package loaded. Once that package is loaded, I now have job limits, not just process limits. So in the advanced admin class, you've got the limit command and system parameters to change your per process limits. These are for the whole job. So if I have 5 processes that each take 5 seconds, that'd be a total of 25 seconds for the job. I could put a limit of 25 seconds, and each individual process would run fine, but once I accrued 25 seconds for my whole job, then I would be killed. The same thing would be true for interactive. You actually get logged out as your login shell gets killed. So I loaded that package. I loaded NQE 33016. But before I started NQE, I ran this gen limits command, which creates the binary database that NQE is going into. And I also quickly looked at the .in file and edited it. And again, we can double check that now since we know it was a process limit that it was hitting. We'll go back to ITSI now in dijlimits.in. And see, I've got a number of procs for interactive at 1024, and for batch it's at 1024 as well. And just to experiment, I'm going to put it to unlimited. Okay. I'll also try running it as roots instead of DAW to see if I pick up roots limits, which were also unlimited for batch. Now that I've made the change, I need to do a gen limits. Okay. QStat. There is one job running right now from TNG2. And no, it doesn't have a job ID assigned to it yet. It's just sitting there right now. Let me try one more thing now. So there's my job, and again, it's still only showing R01. So even though I submitted as root, I'm going to do a JSTAT-AL. And there it is again. That was for root. I was looking for the other one that we had there for, but didn't have a job ID assigned for it yet. This job 9 is just sitting there. There's no job ID assigned for it yet. That's why R isn't showing anything yet. And again, if I bring up top, the job isn't running at all. So I'm going to regress right now. I'm going to stop NQE. Because I have 2 jobs running, it'll take a little bit to do the shutdown. So when I invoke job limits into my systems, the 3 typical things are open file limits get hit, or in this case, this is the first time I've seen this one, nproc actually being set to 0. And the jstat command was the only one to actually get me there. To tell me which limit did I hit. So I was just reacting to a stability problem. I submit my jobs and they're not running. When they come back, it says can't fork processes.
What, I'm sorry, what fork mean?
Fork is how you create a new process.
Oh, okay,
So every time a program starts off, it has to do a fork.
okay. I'm just trying to recall what
Just-
that means.
Go ahead, just ask.
Okay,
So the normal creation of a process, my shell, CSH, would read standard in and say, oh, you want an ls command. So it would then fork off a copy of the shell and then exec the ls command on top of that child.
okay,
So fork is how I create a new PID and a new process,
okay,
and then exec is how I put a new program into that entry.
okay,
So most programs, when you're using the shell, they'll fork and exec all the commands you're typing in interacting with.
oh, okay, all right.
So in this case, the forks are failing because the limit's hit. I can't create any new processes. I'm getting a process limit. Every time you fork, the child picks up the parent's limits.
The other one is called spawn. I think you spawn a new process.
Well, spawn is a common name. There isn't really a system call named spawn.
But that one takes up whole new sets of, there's no limits passed to it, and you can't pass stuff back from, say a fork, the child can pass stuff back to the parent, but on the other one, they can't. It's like it's a totally separate entity.
Let's see here. So I have, spawn is a common term, but I haven't heard of any system called name spawn in
You know
IRIX.
what, there's something that creates, it might be the way that you do the exact, but I don't remember.
Well, there are different things that are going on. We don't have time to talk about different types of execs. One of the problems in the Cray world was when I fork off a child, the child would be as big as the parent. So if I had a 1 gig process, my child would be 1 gig in size, and then I wouldn't be able to do the fork. So I think he's referring to other ways without inheriting the memory limits and stuff like that. And this is really a different class that I teach called IFO, IRIX Functional Overview, where we talk about forks and execs, and reads and writes, system calls, and things like that. Okay. So I was just reacting to my workload not running correctly. Right now, I'm still waiting for it to shut down. And here I now see QSH and CSH as some of the job statuses that are going on there. I'm just going to do a man on QStat, and I can check what that status is. So,
How about increasing the font size?
yeah, that's fine too. Let me get out of that window though.
It's called SPROC.
SPROC, yeah, and there's a new one called NSPROC. Let me save those for Wednesday. Those are for multi-threading. Okay, so SPROC is what OpenMP uses, and NSPROC is what pthreads use. So just for reference, fork is standard Unix to create a new process. And for every fork, there'll be a new PS entry visible with a new PID assigned to it. Then we have SPROC, which is what's called OpenMP. And OpenMP is our multi-threading compiler syntax. So I can say, take this iterative do loop and spread it across a bunch of CPUs. And again, you're creating a new process, but they're sharing the process space. So if I create 4 threads, they can still talk to each other through shared memory. And then the new one is called NSPROC, and that's for pthreads. In pthreads, it's 1 PS entry for the group, for all threads spawned. whereas this one was 1 PS entry per thread. So those are 3 different ways of creating a process. By the way, if you're on Linux, it'd be like clone, and Windows calls it new proc. They all have the same basic concept. I'm going to just get away from that. Go back to our workbook at this point. And also talk to a developer on my next break. Now, it's not my job. I'm really not interested in explaining details about NQE. We're just going to use it in context. I do have a 2.5-day class just on NQE. So the only thing we're interested in is what a job looks like right now. So I thought I'd show you this right now. NQE is a batch interface, but it's basically reading a standard in script and executing it. It then looks at the top of the job for my limits. So if I was in LSF, it's called B sub. If I was in PBS, it's called PBS. They each have their own different syntax. In this example, I'm saying the name of my job when I submit it is going to be named code 1. So when I was doing that status display, that would be the name of the job. EO says standard out and standard error will come back into a single file. I don't like having 2 separate files. I run 10 jobs, I don't want 20 files. So I just combine them into a single output. Then I'm declaring my limits. This is asking for the stack limit. We'll talk a little bit later about the stack. The stack is the portion of the program that keeps track of my jumps. So every time I jump from one subroutine to another, I push something onto the program stack. And the way I get back to where I jumped from is to pull it off the program stack. So the program stack is something that's maintained by the operating system to keep track of where I am. There's actually 2 stacks, one that the user can get to and one that's in kernel space. So if I jump 20 routines deep in my program, I'm going to have 20 things pushed onto the stack. So this is setting the limit. As I go wider in multi-threading, I get larger stacks. If I go 32 threads wide in my application, I'm going to need more space for the stack. The next 2 that I've got here are my time limits. The little t is per process, and the big T is per job. And in this example, I'm asking for 2,500 seconds per process. So if any single process goes over 2,500 seconds of CPU service time, it will get killed. Now, older NQE did the kill. What I'm trying to do this week is get NQE 16 working so that the kernel does the kill. So prior NQE 16 at 15 and earlier, it would PS and look at all the processes there and say, oh, this one's over CPU time, and then it would then send a kill signal from the NQS daemon to that particular process. But now with this job limit set, the NQS daemon doesn't keep track of the job usage, it's in the kernel, and there's a job table in the kernel, so every time a process is running, we keep a track in the job table of what's going on. And that's what JStat is printing out. The JStat command prints out the job table. And JLimit prints out what my current limits are with my current session. So that's a per process and a per job limit. Again, when I regress back, I will no longer be enforcing job limits when I go to an older NQE. And the other 2 parameters I have here are how much memory I want on a per process or per job basis. So I cannot grow larger than 100 megabyte or I will get killed by the NQS daemon or the kernel, depending upon whether job limits are running or not. The last thing gives me a NQS report mailed back to me. So NQE strips all that information off and then says, based upon these resources, I'm going to let you run when those resources are available. So if I've got a system with 200 meg on the system and I submit 2 of these jobs, nothing further would run because each job asked for 100 of the 200 meg. So NQS would not start any additional work until that earlier jobs finish. After this stuff is pulled off, basically the NQS daemon makes a call, a limit system call. And that's what we were looking at earlier. It's called set JLimits. The set JLimits call is where it's failing. When it's doing that set JLimits, the process count is being set to 0 for some reason. And to me, that's a bug. Anyways, within the job, this is standard in. This could be a normal shell script. I could run this program as a normal shell script. The top stuff would be commented out. So I'm just going to do it here. Code 1.nqs. I'm going to put it in the background. And now it's done. And I can't see anything of what happened for some reason. Let's see. Exact J behavior. I think part of it's the shell choice.
So really that NQE is a way to submit process to run, right?
Right.
And you can actually at the beginning of that NQE process to specify all your limits. That's
Correct.
Okay.
So it's like a cron command or an at command or background
Okay.
commands, except they're software that's using limits and then deciding based upon what you ask for when to start to.
Oh, okay.
And that way we don't get too many things trying to run at once.
Okay.
So that way we don't have a 200 meg system and try to run 10 gig of programs. NQS would say, let's not run more than 200 meg. Okay, so it's throttling back my system and controlling the workload. It's like a stoplight on the roads to keep the traffic under control better. Okay. LSF and PBS are identical in concept, just subtly different syntax. We're not really concerned with the syntax. Now what I was going to do here was change my shells. If I change to the appropriate shell and then try this again. For some reason it's still not. Now in troubleshooting these things, there is a command called, in the Bourne shell, set-x, or in the C shell it's called set echo. So I'm going to see what is happening here. It's exactly JLimit, and that's all. Okay, so now it's actually running the script. The exec was causing problems. So it's in the process right now of compiling my application, and actually it's doing the load. It's actually running the code right now. So here was the compilation by the compiler. It's a Fortran program. And here's where I'm actually linking the compiler stuff together into an executable. And now the program is actually running right here as code 1. So I'm running it as an interactive script right now. But I could run 100 of these things and fill up the file system, fill up lots of different things. NQS would prevent the oversubscription of the resources. So that I can't fill up disk drives or fill up memory or take all the CPUs.
However, that's something that the user has control of that, right?
Not, the administrator will control the queue structures, and then the user has to live with what they ask for being put into that particular queue. It's like going to the grocery store or the bank, and you've got different lanes for different things. And if you get in the wrong lane where commercial people have coins being counted, you're going to end up waiting a long time. Maybe all you needed was a check cash, and you could have gone into the express lane. So that code 1 now just ran, but it was running interactive. And you were asking about timex. SS usage is an IRIX specific timex. It gives me a little bit more information. So that particular code took 69 seconds of stopwatch elapsed time or wall clock time. So if I timed it with the stopwatch, it would come out at 68.39 seconds. Of that, 62.63 seconds was executing my program, whatever the compiler generated. Also had 3 seconds of system time. This is making calls to the kernel. In this case, it's mostly reads and writes. And then I've got some other metrics. How many page faults did I get? Major, minor. Major page fault says it came from swap. Minor says it came out of memory. This field is always 0. There are no swaps on IRIX. We swap pages, but not entire processes. So that's a legacy counter that standard Unix had that we don't use. Question? Okay. We'll talk about swapping pages versus swapping processes. Original Unix and Cray Unicode swap the entire process out of memory. IRIX does not do that. So that'll always be 0. Then I've got the number of blocks that were transferred by the application to disk. I read 15 blocks and I wrote 137 blocks to disk. And then we'll talk a little bit later in the week about context switching. I did 40 voluntary context switches. In other words, I made a system call in the kernel, and 40 times the kernel did not give the CPU back to me, it gave the CPU to somebody else. A context switch is how I switch a CPU from one program to another. And then the last one here was involuntary context switches. It doesn't look like it wraps. It looks like there were 34 involuntary context switches. These are due to clock interrupts. Every 10 milliseconds I get what's called a minor clock interrupt, and that gives the kernel the opportunity to say, should somebody else get the CPU? I'm going to come back to this when we talk about CPU scheduling. So voluntary are driven by system calls. Involuntary are driven by the clock interrupts, and also something called slice size. In your advanced admin class, there used to be an exercise that you'd adjust slice size and then see how much context switching you did. Again, a context switch is taking a CPU, disconnecting one program, saving everything off so the program can restart, and then a new program going into that CPU. It's also referred to as a preemptive time slice operating system. Okay, Linux and NT are both preemptive time slice operating system with clock interrupts to give the kernel an opportunity to schedule somebody else in the CPU. And also then at the end of this thing was my job report. And in here I can see my elapsed time. Here's my code 1, so there's my 68 seconds, 62 for user, 3 seconds per system. But I can also see I waited a little bit for CPU, not much. And I also had a little bit of wait on disk, but not a whole lot. And I have turned on charges on the system. So it looks like, I think that's $12 that I got charged for running that particular 60-second job. Okay. So I think I've got it set to something like 20 cents a second is what I think I set it to. But that's up to the site to determine what they're charging. And I turned it on this week because I'm playing around with new software, in particular NQE. So that was running the same script interactively. If I submitted through NQS, then NQS would look at the stuff at the top and then decide when to run. And I may actually wait in the queue before I actually get running. Okay. And LSF and PBS are identically the same. They just have slightly different command syntax. The concepts are all the same. In fact, they've got scripts to convert from one type to another, so you can take a PBS script and look at it. In fact, in my directory we're going to get into here, I do have examples of PBS jobs and also LSF job samples. So if I look at LSF, at the top it was B sub syntax and all the arguments I wanted. And if I look at a PBS job, at the top it's pound PBS with the arguments that I want. But underneath that is going to be the same, basically a shell script syntax.
When I say that those parameters are controlled by the person who submitted the job, it's because that person actually set those parameters, right?
Yes. These particular parameters were set by the user.
There is another set of parameters that are set by the administrator or something like that, or not?
For what?
For the administrator, so, because these are parameters that the
The
user
user
set,
declares,
but
right,
it should be a limit, right, for that user
right,
of those parameters. It's not like you can go and put whatever you want.
right.
Okay,
So the administrator can set the user limits with that ULDB command. So that they can say, everybody defaults to this, but DAW, I don't like him, I'm not gonna let him have as much memory.
okay,
And then I can adjust it there. Okay, so when I submit to NQE, NQE will say, here's the limit you asked for, is it within the limits of the user database? If not, then you get rejected.
okay.
If it is, then it will make the system call to set the limits to what you asked for. So the users are specifying this stuff here. But then the administrator has to configure it all. Okay. And right now, we only have one queue with nothing configured to it. Later in the week, I'm going to put up multi-queues. So there's just one line right now, and the resources aren't really being used. But in the end of the week, I'm going to have a small, medium, large type of concept. So big memories will go into large, small programs will go into small, and then I don't have to wait behind a big program to get my 5-second thing running. Okay? And note, by the way, we now have status off. That's because of those port failings and the problem that I talked about earlier.
How come what you're typing isn't showing on the screen?
Sorry. Not sure where window drops off.
Ah,
Just let me know.
okay.
So it's going to shut down NQE and bring up an older version. Looks like it was shut down. Yes. Just double checking. There is still some NQS stuff sitting there. Again, I'm just doing what I have to do to get things running, but there's a command called NQE maint. It allows me to select which release I want to go to. I'm going to fall back to 3.15 and then set that as my default. Running as root, everything looks okay. Tail gets the NQE info. So now that stuff was there at the end anymore. That looks okay. So I'm going to restart NQE now. So I'm just double checking things. I want to get back to something that's working, and 33015 is now getting rid of the job limits that we've been discussing for a while now and falling back to an older technique. PSEF, I'm going to grep NQE. Okay, so I do have the NQS daemon and the net daemon running, and something called the server and collector. So everything's up and running. Now I'm just going to try again. QSub code 1.NQS, QStat-A. Looks like it's running. Up top, and now I can see the thing running. Because it was not hitting that process limit that the 16 version had a problem with. So, you're going to basically copy all my NQS job examples as a starting point, and then we're going to submit them and use them to tweak. So I've saved you some typing to give you a starting point, and then you can adjust the jobs from there. Okay, so I'm going to submit, so I do a QSub code 1.NQS. I'm going to submit code 2.NQS, code 3.NQS, and code 4.NQS. And do a QStat-A, and over on the right, the R says that they're all running. If I do a QStat, I can also see I've got 5 jobs, and they are all running right now. And if I bring up top, I see a couple of them. There's still a compiler running, but I've got code 2. There were 2 code 1s fired off, code 3. And I don't see code 4 in there yet. Code 4 might have blown up by now. QStat-A. Code 4 is no longer there. So I submitted 1, 2, 3, and 4. 1, 2, and 3 are still running. Code 4 is finished. So with QSub, I submit the work. With QStat, I view the status. And then the output comes back in the directory I submitted from. Okay, so there's the code 4 that came back at me. So I'm going to take a look at it. I already know what's the problem, but let's just look at it. So here is the set echo or set-x. So every time the shell parses a command line, it does a plus sign and then echoes what was parsed. So some of this stuff was in my .login. Basically something called modules that we'll get to a little bit later. And then here I actually see the module loaded. I'm running with a 721 compiler as my module choice. The advantage of modules is that it allows me to have multiple products on the system at the same time. So one user could be compiling with one compiler set and another user could be testing a completely different compiler and library sets. Okay, so modules changes my path, my man path, and my library path. In fact, let me just do a module avail to list all the modules that are available. And undo right now, those are all the different pieces that are available. So I could load total view, I could load various flavors of workshop. We'll talk about Mpi and Message-Passing Toolkit. And this is the module that we presently are working with, the MIPS Pro compiler for 721 release. Okay. So modules allows multiple people to have different product environments at the same time. Now, I was looking at that code 4, splat 15. So after the module command where it said which modules are loaded, and here I see the loaded one was MIPS Pro 721. Then I actually, in my job, echoed what my current working directory was. We'll talk about that a little bit later. I'm also grabbing some information from the program to get its size. Then I'm showing what modules are actually loaded. Then here's my compiler. Now code 4 is a C application. So I see the C environment and I'm doing a -show. So the -show is giving me all this other stuff. And that way I know what MIPS I'm set for, what ABI I'm using. So it was the -show that's giving me all the arguments being passed from the compiler to all the pieces. Let me get back here. And then right here, here's my problem. Code 4, error, malloc, resource temporarily unavailable. What does that make you think?
That's memory.
Memory. It's memory. Okay. Now today I'm just getting oriented and trying to get a working system. So I'm responding to the problems I have as I throw the workload at the system. So I'm starting off with a very simple workload, just code 1, 2, 3, and 4. And by the end of tomorrow, I want to slam the system with 5,000 jobs if I can to see what it does. Okay? So I'm not stress testing the system yet, I'm just taking care of reliability. So, if I have error on a memory problem, what would be a good thing to think about? What command would be of interest to me right now? I would start with swap-s. Okay, swap-s is telling me about my memory. So right now there's nothing allocated, but I have a 1.5 gig that's presently reserved. Now, we don't know how big due is yet. So in my inventory process, that's why I like to do the inventory first, but I'm just reacting to the case study I have here. So if I take a look at HI&V, I see that I've got a 2 gig system. 16 CPUs, we got about 15 disk drives or so. So it's a 2 gig memory system, and I've already got 1.5 gig reserved. Okay? That leaves me only 643 megabytes left. Now code 4 was already at almost 400 meg when it failed. Gee, 600 meg, what did I have here? With the swap. I had about 643 meg still available on my system. It looks like I blew up at about 400 meg. 300 meg, approximately. Okay. Now, we're responding to the problem. If I look at code 4.c, that message was coming out of the application from right here. So it's basically going to build a heap using the malloc system call and then stuff data into the heap. So it's doing a malloc, and the size of it is 1 really, it's just a null structure here. But then if that malloc fails, we then do a P error, then it says code 4 error malloc, and then we get the system error number converted into ASCII. That's what P error does. So P error printed out that resource temporarily unavailable. Okay? So if I were to try to run it interactively, code 4, ampersand sign, top, I'm just watching, there it is at 500 meg, and then I get that same error. Resource temporarily unavailable, and code 4 went away. So it's running out of memory. Okay. So I have several options here. The first option would be to resize code 4. It's blowing up at 500 meg. And so I can make code 4 smaller. But in this case, that doesn't help us because I got a large data set. Second thing I can do is add more memory. But that costs money. The customer may not want to spend more money on memory, particularly if code 4 is not very important like code 2 is. The third thing I can do is find out if I'm out of memory, who's using it all. Okay? So there are 2 commands. Again, we're going to come back to this later in the week. I'm just responding to my problem here. I did a swap-s to look at my reservations and allocations. Okay. And I saw that I had 1.6 gig that was already reserved, 600 meg that was available. We haven't actually gotten code 4 running, but it will grow to a gig in size. And there's not a gig available on the system. Okay. Now, if we don't have virtual memory, enough virtual memory, what are my options now? So the S is describing the entire memory map. We have physical memory, we have swap, and we have virtual swap. So if I can't fix the application, my other option might be to add more physical memory, add more physical swap, or possibly add virtual swap. Now, what's wrong with using virtual swap?
The process really needed.
It's not really there. Now, politically, here's the best way to look at it. If virtual swap is off, the malloc fails. And that's what we saw. So I got a malloc, resource temporarily unavailable. In other words, it was the program's fault what to do when the malloc failed. So virtual swap off, it's the program's fault. When you turn virtual swap on, the malloc is successful. But then when I actually try to use the memory, I run out of memory and I have to kill. So when virtual swap on, the kernel will kill. And that's the reason we normally do not advise virtual swap, because we do not want the kernel killing things. In other words, with it off, it's the program's fault. With it on, it's SGI's fault. So if I had a database server running, Oracle being the largest thing on the machine, and somebody comes in, logs in interactive, and fires off a whole bunch of LSs, takes up all the memory, and then Oracle tries to malloc. With it off, the malloc would fail, and it's up to Oracle to say, well, what do I do if there's no memory available? With virtual swap on, the kernel will kill Oracle, which would be bad in a fail-safe situation. And the kernel, when it kills, usually kills the largest thing in memory, which is usually your important application. So in most markets, virtual swap is off by default. But in a compute server market with a batch interface like NQE, I can turn it on and take advantage of it. Okay. There's something called a sparse matrix solver. Basically, we malloc a big array, but then we don't fully populate it sequentially, like stellar physics. I'm counting stars in a cluster, and there's a whole bunch of black space between things. So my array may be my grid for space, and I pack a bunch of stars in one area of the grid, and then there's a whole bunch of white space, and then I've got another star cluster. So in a sparse matrix solver, I've got a lot of portions of my array that don't have any data in them. And we also refer to these things as gather-scatter. I gather all my data from pieces all over the array, and then I write them back in a scatter-type fashion. Sparse matrix solvers don't use all the memory they ask for. Okay, so they ask for a big thing, and then they only use a piece of it. Now earlier when I was looking at code 4, it's 15. One of the things I grabbed at the top was the percentage of the array. So in code 4, I've got a parameter that says how big is the array going to be, how many times do I walk through the array to number crunch it, and then this one's saying I'm going to use 65% of the array that I allocate. So I've set up code 4 to be a sparse matrix solver. If I set that to 99%, then it would use all of its memory. So what I'm trying to say is that code 4 is only using 65% of my memory. So if it's a 1 gig process, I only need 65 or 650 meg. And the rest is never really going to be used, and that stuff can use virtual swap. So by having virtual swap on, I can actually increase my memory utilization. Because I can get more things in physical memory. I can pack memory tighter. Which also means I'm going to swap more. Okay. So in my example, I could fix the application, which wasn't an option here because I said we can't change the codes. I could size the OS, and that's one thing that I've got to talk about here for a second. And then I can add more hardware. Or run less codes. And in this example, not even one code 4 runs in my system, so that's not an option either. Now for sizing the OS, I've got a 2 gig machine and I'm trying to run a 1 gig process and it says can't do it. So I've got to find out where's my operating system memory going to. Okay? So before I add more memory, let's make sure that the memory I have is efficiently being used. Okay? So swap-s told me about the entire memory space. There are 2 other commands relevant to me at this point. One is called pmem, and one is called ipcs-am. And one other thing you want to look for is miser. So I got a 2 gig machine, and I'm looking at swap-s, and it says I've got a bunch already reserved. Swap-s shows I've got 1.5 gig already reserved, and there's no work running. 2/3, almost 3/4 of my memory is already being used. I do have a code 2 running right now at 23 meg, but that's small.
That it said that it reserved 1.5, but how do you know how much it is using?
Here's what it's actually using.
Oh, so it's using what is reserved.
Right. But there are 2 things that are showing up here that will not show up for live processes. One is miser and one is inter-process communication. When miser starts up, it reserves memory ahead of time. If I do a PSDF and correct for miser, it is in fact turned on, and I'm asking for 1.5 gig of memory for miser. So that's one place where my memory's going. We're going to talk about miser later in the week, but work that runs under miser never swaps. You are guaranteed memory for miser. You will never have swapping for miser work. So when I start up miser, I got to make sure that it reserves memory ahead of time so that nobody else can take it from miser.
So miser is like what? Like, I don't understand that concept.
We'll come back to miser. Miser is like a restaurant reservation system. I call up the restaurant and say, I want to come in at 7 o'clock tonight. I got 10 people. We want to be there for 2 hours. And then miser goes to a reservation book and reserves that time for you.
In this case, it's when.
Yeah, and CPU time. Okay.
And how you determine that the application is running using miser?
Let's come back to that, but when you're doing a PS, there's a C option. And this class, if it says B or BC, says that it's running under miser. And again, today's just kind of a spread of all the different things going on.
Okay.
So we're going to come back to miser on Thursday.
All right. So, which means that, you know what? I have this doubt in my mind. So it means